There we go. Moving along in chapter 7, we're finally getting to something that is totally new to us as far as content from the two courses you've had. Today we're going to talk about something called a vector. And the other day I said when we were talking about arrays, a common word that went with arrays was static. Static meaning it doesn't change. But here today we're taking a look at something called a vector, and this is dynamic. Dynamic means that it can change. And what can actually change is the amount of memory we're using. When we did the array, static, done, we declared the size and that was it. But this vector is something that we're going to be able to use if we want. You won't use it very much because when you get to 162, we learn about something else that works a little bit better as far as dynamic memory allocation. But I'm going to start with looking in the book because I know you all read the book, but this is this whole idea of vectors is something that wasn't normal for C++. It is in what they call the standard template library. I can remember when string was not normal and it was added to the standard template library. Now it's included and you can just get up and get ready and use it. But what happens is, and if you read these data types and algorithms are programmer defined. That means somebody wrote it and then added it to the C++ language. It's a built-in that we need to include and incorporate. Okay, so what is a vector? Here we go. We go on with the vectors. It's like an array, as I mentioned before. It's a sequence of values. It's like a list. It'll be homogeneous. They're all the same data type. And it doesn't have to necessarily be a primitive data type. There's all kinds of data types we could use. It stores elements side by side in memory. And as we talked about arrays recently, we said the array name was the address, and then what was in the subscript was what happened next, what came next, what came next. And we always took that and multiplied it by the size of the data type. Okay, some differences, these are some similarities like arrays. Where they differ is we don't have to declare a size. We can declare a size, but and that works with a certain limit, but there are times we want to add more, we want to decrease the size and free up memory. So that's the difference, is we don't have to know the size up front. Okay, again, it will never be full because we can always keep adding something, and it's easy to find the size. I may have had an array of size 100, but I really only wanted 23 elements in. But with a vector, I can find out right away. Now, pound include vector. Like I said, it's part of the standard template library. It's a built-in that we have to include so we're able to use it. And if we start by taking a look at how do I declare it? How do I declare a word? Now, how do I declare a vector? Well, let's see. After I put in the preprocessor directive, which we're starting to become familiar with that term, I want to declare a vector and I want to call it numbers. Again, this is going to be really similar to what we did with an array because this is going to be an address. I'm telling it I'm storing integers. Okay, I have a couple of other different ones. Here I'm declaring a vector of size 10. Again, up here I didn't have to declare the size, but I can if I want, because I might want to put a certain bunch of numbers in to start early on, or definitely have 10. This next example, I can declare an array of size 10 and fill it all with 2s if I'd like. So lots of different options, lots of different, I almost think of these like a constructor. The default, there's one argument going into my parameter list. Here's 2 arguments going over the parameter list, and so on. And as I mentioned, we can have a vector of all kinds of data types, ones that we make up if we so choose. Okay, so that's us getting started with vectors. And
Professor, can you go back?
Yeah.
So On the bottom, the vector int numbers 10, 2.
Yep.
So the first one in that list is the size.
Correct?
Then what if we keep adding different values? Would that,
Well, this will make them all 2.
right? So what if we had a
It'll
3
fold.
after that? Is
Um,
that a thing too, or just,
well, you know, when I do vectors, I almost always use this first one because I hardly ever know what I want to put in it right away. So to answer your question, I don't know.
okay,
You know, there's this table in the book, table 7.3, table 7.3, that discusses it, you know, here, and it initializes it with all A's, but it never really says, you know, can you, well, you're going to see in a minute when I take a plain vector and how I can fill it with a set of values. I think that might be more of what you're thinking about.
okay, thanks.
Okay, this is just the declaration. We'll look at that whole implicit idea in a couple seconds. Okay, boom, 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 boom. And a couple of seconds just went by, bam, just like that. Okay, I like doing that. Bam. I don't know if any of you remember, there was a chef who used to be on TV, and he'd throw in spices into the recipe and he'd holler, bam, all the time. Anybody know who that was? Nobody ever heard of a guy named Emeril Lagasse? All right, somebody laugh at my jokes, you know, just smile. All right, thank you. All right, so here's more, I think, Adam, what you were asking about. I'm going to declare a vector of integers. I'm going to call it numbers, and I'm going to fill it implicitly. I'm going to fill the first 4 places up, and I want to store the numbers 10, 20, 30, and 40 to get started. If I was doing Fibonacci sequence, I might declare it and put in the numbers 1 and 1 to get it started, that kind of idea. Okay, going back to the last page. When we declare a vector of a certain size, we can use square brackets with it, just like we did an array. So if I start looking over here at this second one, vector int numbers, I could use numbers square bracket too, if I wanted. But it's only when I declare the size of the array. Okay, I'm coming back over here. That was just a little side note. All right, so you had taken a look at some code listings, and here was one, 724, and you see the include of the vector, and you see a declaration of 2 vectors, and we're given the sizes. So that means if I want, I can use the square brackets to access those first few elements in the vector. You know, it's one of those, well, if I'm doing that, why don't I just make it an array? Well, that's another thing. Okay, now as we go through, you can see we're doing the first 5, the hours and what their rate was, because this was a program to calculate salaries, and we're straight up using the square brackets. So that's a little bit of a similarity to what's going on. When we then jump over to code listing 727, that's when things started to get interesting. Because now, if I don't know the size of my vector, what if I want to add something to the vector? What if I want to take something out of it, right? Delete it from the end. What if I want to know how big it is? Well, remember in the beginning, I said this is it's like a class that somebody wrote. And in order to do operations on the vector, we need to use some function names. So if you typed in program 727, you're going to start to get an idea of the first one on my matching list. And that would be what? One of these is in code listing 727, and you can match it up and tell me what it means. Well, let's see. Push back 25. These are the functions that are available. Size, pop back, clear, empty at 5. All right. Value located at, returns true if empty. Oh, that should be an easy one, right? Which one returns true if empty?
Empty.
There,
Empty.
empty. That's a good one. Removes last. Which one removes last?
Pop back.
Pop back, right? And when I remove it, I'm going to be returning a value. So as you'll see in an example in a little bit, Pop back is returning a value for me. Which one gets the number of elements?
Size.
I had to hop over those. Size. Okay, size is going to be what clears all elements. That's kind of an easy one. That's clear. Which one is going to add to the end?
Pushback.
Pushback, right? That's going to add to the end, which means value located at, I could go at 5 and see what's there. All right, so what's the question here about at 5? Where would at start? Would at start at 0 or would at start at 1? Something to keep in mind. So let's take a look at, here's the first example. In 728, you're going to see I declare a vector, I call it values. Okay, I am going through here and I'm saying to myself, well, wait a minute, I didn't need to put 7. What could I have put instead of 7?
Size.
Vector dot size, right? So I could have used that. And it looks like, what am I doing? I am adding to the vector values whatever count is times 2. So it looks like I'm going to add 0, 2, 4, 6, 8, 10, and 12. I'm pushing all those values on. Now I have a method called show values, and you notice what I'm passing in. Just the name of the vector, which is the address. So let's go over and take a look at that method real quick. And there it is. I'm bringing in, I'm bringing in, just like we did array of ints kind of deal, I'm bringing in a vector of ints. And I'm going through, and now I'm using the square brackets to print them out, to go to the certain location and print them. Taking a look at the example down here. Pushback 1, pushback 2, pushback 3. Pop back. I'm getting a value from pop back. It's eliminating the 5. Here we start talking about the size. I keep popping values out. I have D2L. I don't know if I gave these to you on D2L or not, because I didn't make all these code listings. 731. Here's an example of if my vector is empty. Okay, if it's empty, then there's no values to average. Otherwise, I read them in one at a time. I grab them because of their square brackets, because I know the size now, and I can pull the values out. Okay, and finally on this last page are some of the functions. And we just talked about them: at, clear, empty, pop back, push back, resize, and swap. Couple of things to work with. Page 459.
Interesting.
Bless you. Okay, 459, number 17. Down here is a program called name search. All right, so I'm on D2L. You should have 2 files, girls' names and boys' names. I want you to write a program that will read all the items from the 2 files, store them in 2 separate vectors. Okay, the user should be able to enter a boy's name, enter a girl's name, or both, and then you should be able to find out if it's in that list or not. So this is the top, 100 girls' names from 2000 or 200 from 2000 to 2009, top 100 boys' names. So you're going to enter a name. If it's a girl's name, it's going to check the girls. If it's a boy's name, it'll check that. So what I'll just have you do is, if I enter a name, Chad, you check the boys list to see if it's in there. You check the girls list to see if it's in there. That way we'll find out if it's in them or not. So it's just a matter of going through, but you're reading the data from those data files, storing them in vectors, and then you're going to ask the user for names and search through the vectors to see If any, which one or both list it's in. Second program I'm gonna have you write is rewrite the Fibonacci sequence with vectors. Like I said, we could initialize the first two to 1 and 1, and we just did a program with Fibonacci sequence, right? So yeah, somebody nod at least, maybe.
Yes.
Yes, okay. This
Yes.
time I want you to rewrite that with vectors. So short lesson, got to get your hands dirty, play with the mud. I don't know why my 9 faded there. I want you to do the name search. So you have to go back and work with files and everything. Fill those names in. I want you to then also rewrite the Fibonacci sequence using vectors.